If you're transcoding your videos using software-only encoding, in this video you learn how you can slash CAPEX, OPEX, and carbon emissions using NETINT T408 ASIC-based transcoders while maintaining the same quality as software-based encoding. So here's what we're going to do. We're going to encode on the same computer using two different techniques. One is FFmpeg using CPU only, and the other is with 10 NETINT T408 transcoders installed in the system. We're going to use the same test file and encode to the same encoding ladder that you see here, retrieving from RAM and delivering to RAM, and then we'll see how many encoding ladders we can produce using each of these techniques. And here's the encoding string we'll use for the X.264 encoding. We see we're retrieving from a RAM disk, delivering to RAM disk, and very fast preset here, and 2-second gop size here, and then basic CBR encoding for all the 5 rungs. And then here is the command string for the T408 encoding, again retrieving from RAM drive, storing into a RAM drive, 2-second gops, and CBR-based encoding. So here's the start of the cost side. The Dell server cost around $3,200 new, and if you're encoding with software only, you don't need to add any hardware to that, so $3,200 is your base cost. If you encode with the 408 transcoders and you add 10, that's another $4,000, but that price can come down significantly in quantity. So the starting cost for that unit is around $7,200. So in both cases, I'm going to dial into the system remotely via SSH and Bitwise. And I've set up 4 terminals here. I think I have a pretty good idea how many simultaneous ladders I'm going to be able to produce. Just wanted to show you in this utility that we are on the Dell computer with the AMD EPY 7351 16-core processor with 32 total cores. And let me change this to top so we can see what's going on. And we will start running 1, 2, 3 simultaneous encoding ladders. And we're going to see which ones get to and stay at 30 frames per second. Usually it takes about 30-35 seconds for FFmpeg to catch up to real time. So here we're getting close, here we're getting close, here we're getting close. And we see that on this 32-core computer, we're using around 800, 800, 800, so we're at 2,400 of the available 3,200 CPU, and we're at 30, 30, 30, so that's good. And now let's try number 4 and see what happens here. And the 4th encode takes CPU resources away from all the others, and we see dropping from 30 to 29 here, from 30 to 29 here. And let's see if we recover and if this one ever gets up to 30 frames per second. Okay, so we can see everything's going in the wrong direction here. We've got, we're right around the 3200 total CPU down here in top utility. We're at 24 frames per second here, 26 frames per second here, 27 and 27. So using the very fast preset on this machine, we're able to produce 3 full encoding ladders at 30 frames per second. Now let me set up the machine for the T408s and we'll come back and see how many ladders it can sustain. Now we're about to run the T408s in the same system, and we've got a much busier desktop because we're going to be encoding many more ladders. So let's get this out of the way. Just wanted to show you that we're working on the same system we were a moment ago. It's the AMD EPYC 7351P Dell with 32 cores. So that's the system, and we'll look at top in a second. This is a utility from NETINT that shows the load on the decoders up here, decoders, and encoders over here, and that will quickly fill up once we start running the encoding ladders. So let's get started. I'll come back to you when they're up and running. So now we're up and running. We see the load on the decode and the load on the encode. And what's happening is now that we've got 21 encoding ladders running, the T408s in the system are going through some load balancing. So what the software that sits over the T408s does is it divides each encoding ladder into the individual rungs, and then it sends those rungs to the different T408s depending upon the load. And we'll see some of these as low as 73, some as high as 81, and those will gradually come to a similar level and a little bit higher to get to full utilization. In the meantime, we've got, 3, 6, 9, get this out of the way, 12, 15, 18, 21 ladders at 30 frames per second. And now we'll see if we can get these up to 30 frames per second to give us the 23 that we're targeting. While we're waiting, let's observe CPU utilization in top here. And we see that all of the encoding ladders, so there's 23 encoding ladders here running, and they're averaging around 42 to 44% of CPU. Now that's not of 100%, that's of 3,200%. So we're still only using about 1/3 the capacity of the 32 cores, which is really going to save us big when it comes to power consumption. And we'll look at those numbers in a moment. So we've got 30 through all of these, and 30 through all of these, and we're at 30 here, or we're teasing with 30, coming back and forth. And again, what's happening is the system is load balancing among all of the individual encoders and decoders. And now we're seeing 30 frames per second on all 23 encoding ladders. So let's see what that means from a numbers perspective. Looking at CPU-only encoding, we see that the hardware cost was $3,200. We got 3 encoding ladders for a cost per ladder of around $1,067. With the 10 T408 transcoders, the hardware cost us $7,200, but because we got 23 encoding ladders instead of 3, the overall cost per ladder was $313 for a savings of 71% on CAPEX. In terms of watts per hour, because the CPU was so efficient with the T408 transcoders doing the encoding, we actually used slightly less power here than we did here, and the watts per ladder, because we only got 3 here but 23 here, was 96 watts per ladder for the software-only, CPU-only transcoding, and 12.5 for the T408 transcoders. So that's going to reduce OPEX, your electricity costs, by 87%. And obviously, you're going to see the same effect on carbon emissions because those are a direct result of your electricity spend. So we're dropping your carbon emissions by 87% as well. Well, those are the numbers. What about quality? Well, this results graph from the Moscow State University tool measures the 1080p at 5 megabit per second files, comparing the NETINT in red with X.264 very fast in green. And what we see is that NETINT had a VNAV score of 96.16 as compared to 94.12 for very fast. And the same result with PSNR, where the NETINT file produced a PSNR score of 42.50 as compared to 41.17 for very fast. Now, we didn't measure the numbers relating to medium because on this AMD computer, you might be able to get 1 encoding ladder, and the numbers obviously would be dreadful. Few people use X.264 medium for their live streams, but it is a valuable benchmark. And in this case, the NETINT clip actually exceeded medium quality, 96.16 again, to 95.78. And again, we saw the same thing with PSNR, with NETINT at 42.50 and X.264 medium at 42.08. And that brings us back to what we claimed at the start. With NETINT's ASIC-based transcoders, you slash CAPEX by 71%, OPEX by 87%, carbon emissions by 87%, all at the same or better quality than you get with your software-only transcoding.